Determining a model for a real-world scenario can be difficult. Let's look at how to model the relationship between the number of bounces and the height of the rebound of a tennis ball. Here are measurements for the maximum height of a tennis ball after bouncing several times on a concrete surface. Which is more appropriate for modeling the maximum height h in centimeters of the tennis ball after n bounces? A linear function or an exponential function? Use data from the table to support your answer. Since this table reflects a real-world scenario, the data in the table may not be exactly linear or exactly exponential. One method that can help you find an appropriate model is to graph data. If the data are linear, the values can be modeled by a straight line. If the data are exponential, they can be modeled by a smooth curve. But let's look at it another way to check. A linear function of the bounce height would decrease by the same amount for each successive bounce. Here is a table of the bounce numbers and the difference between consecutive heights. That's the previous height minus the current height. From the table, we can see that the differences in heights between successive bounces are not close to consistent. The differences are decreasing with each bounce, so the function is not linear. An exponential function of the bounce height would decrease by the same factor for each successive bounce. If we calculate each ratio, it looks like each successive bounce is about half as high as the previous bounce. Thus, it seems the constant ratio is around 5/10, so an exponential model is reasonable. Regulations say that a tennis ball dropped on concrete should rebound to a height between 53% and 58% of the height from which it was dropped. Does this tennis ball seem to meet this requirement? Most of the ratios are between 53 and 56%, so it seems reasonable to think that this ball meets the requirement. Write an equation that models the bounce height h after n bounces for this tennis ball. This can be modeled by an exponential function, so the equation will have the form height equals initial height times the constant ratio to the bounce number power. The height will be represented by h. The initial height is 150 centimeters. The constant ratio is 5/10, and the bounce number is n.